back again for part 2 of service calculations. Today we're going to be talking about the dryer. We're going to talk about our range and the calculations that are involved in coming up with that range number. And then I'm also going to go ahead and put furnaces in because it's a real short part. Okay, so we'll start off with a joke. Okay, so a man excitedly comes home and tells his mother that he's going to get married. He says, "But wouldn't it be fun, Mom, if we did a little test? I'll bring 3 women home, set them on the couch, and then you can try to decide after talking to them which one it's going to be." So the mom agrees, and the man brings home 3 beautiful ladies, sets them down on the couch, and they chat with his mother. After they've chatted for a while, the man looks at his mom and says, "Ma, which one do you think it's going to be?" Mother says, "The redhead in the middle." The man says, "That's amazing, Mom. How did you know?" Mom says, "Because I don't like her." Okay, so that's a joke for today. Alright, so you can go ahead and turn your code books to Article 220.15 or 54. Excuse me. Okay, yesterday the last video, and as you can see, it's casual. What is today? Tuesday? Casual Tuesday. But anyways, on the last video, we had talked about our general lighting load with small appliance and with our longer branch circuit and the calculations for that. If you haven't watched that or you have questions about that, you can go ahead and rewatch that. And then, of course, leave comments if you have questions. Okay, so we're going to start in Article 220 at 220.54. And if we go to 220.54, it tells us that for its electric clothes dryers in dwelling units, right? So basically what it's saying there is that your electric clothes dryers, your total load is going to be the minimum of 5,000 VAs, right? But if your nameplate of your dryer is more than 5,000 VAs, it says that we have to use whichever is greater. So now if you have a smaller dryer and it's going to be less than 5,000 VAs, then you use the minimum 5,000. But if your dryer is, let's say, 6,500 VAs, then you have to use that number, the nameplate number, because it's the largest of the two. Okay, so dryer 5,000 VA minimum, and then if your nameplate is larger, use that number. Okay, use the number of the nameplate. Okay, so, and that's the dryer. I mean, that's all there is to it. You just take that number and put it into your calculations. Okay, so let's go ahead and jump to our range calculations, because those are going to be a little bit more in depth. Alright, so let's go ahead and turn to 220.55. And 220.55 is electric cooking appliances in dwelling units and household cooking appliances used in instructional programs, excuse me. Okay, so basically they're talking about any of your wall-mounted ovens, counter-mounted cooking units, or your actual full range, which is the cooking unit and the oven part, right? Now, one way that this gets a little more complicated is because if you turn the page, you look at table 220.55, there's a lot of numbers there that we have to kind of think about, right? Okay, so what we need to do is we need to first of all figure out whether this is one circuit we're dealing with, right? Or if it's going to be multiple different circuits, and then how much are those circuits going to be, right? And so what we're going to do is we're going to look at below this table. If you look below the table, you're going to see there's note 1, 2, 3, and 4, right? Note 1 says over 12 kilowatt through 27 kilowatt of range is all the same rating, right? So if you have, let's say we have 3 ranges, right? So okay, so we have 3 ranges. Range 1, range 2, range 3, all at 15 kilowatt, right? So then what we need to do then is we take since they're all the same, we take our 12 kilowatt rating, according to that note, and subtract that out. Okay, so 15 kilowatt minus 12 kilowatt equals 3 kilowatt. It says for every 1,000 on the note 1, for every 1,000 over the 12 kilowatts is going to be extra 5%. So we take our 3 times 5% equals 15%. Okay, so that 15% then needs to be added to our demand factor in column C. Okay, so how do we find out where in column C we are? Well, we have 1, 2, 3 ranges. So on number of appliances, we're down to 3 at 3. Okay, follow that all the way across, and our demand factor is going to be 14 kilowatt. Okay, 14. I'm going to say 14,000 watts, right? Which is the same as 14 kilowatt. Now we're going to take it times 1.15, right? So we can go up, and then we get okay, 16,100 kilowatts, which equals 16.1 kilowatts, which is also equal to 16.1 VA or kVA, right? Kilowatt, kVA are equal, and we are using kVA for the rest of our formula. It's just going to be easier if we just use kVA. Okay? So this is only going to work if all of our ranges are the same, right? If they're all the same, then we subtract 12 from our kilowatts to get our 3 or our remainder times 5%, that percentage, then we times by, in this case it was 14,000 because we used the third row down because of 3 ranges. If we had 4 ranges all the same, be the same thing, we would just use the 4th row, which is 17%. That makes sense? Okay, so let's go ahead and move on to if we have ranges that are of different size. Okay, so if we look at informational note, or the note 2, it says for ranges over 8 3/4 kilowatt this time, through 27, of ranges of unequal ratings. Okay, so basically what it's saying there is if we have the unequal ratings and it's 8 3/4 kilowatts and larger now instead of just 12, then we're going to go ahead and we're going to take, we're going to add up all of our ranges. It says here, basically, let me read what it actually says here. Adding up the ratings of all the ranges to obtain a total connected load using 12 kilowatt for any range that is less than 12. So if let's say we have one that's 9, we have to move that up to 12. Okay, and so we add them all together, and then we divide it by the total number of ranges. Then the maximum demand in column C will be 5% of each kilowatt or major fraction thereof that exceeds 12. Okay, so what does that actually mean? So let's do an example. I'm going to say I have 3 ranges again. Okay, so we have 3 ranges. Range 1 is 10 kilowatt, range 2 is 12 kilowatt, or 15 kilowatt, and range 3 is 17 kilowatt. So range 1 is less than 12, so we have to bump that up to 12. Because 12 kilowatts is the minimum. Now what we're going to do then is we're going to add these up to get a total. So we have 44 kilowatts. Okay, my math is right anyways. Now we take this 44 kilowatts and we divide it by the total number of ranges in the problem, which is 3. Okay, so basically 14.6 repeating. Right. Now, it says there, then after this, we have to take and subtract 12 kilowatts out of this, and then our total kilowatts, 1,000 kilowatt or large or more, or each 1,000 kilowatt, sorry, or major fraction thereof, is times by 5%. So 14.6 minus 12 gives us 2.6. This is a major fraction, right? It's above 5. So we're going to say is equal to 3, right? We're going to take that 3 times our 5%, which gives us 15%. Okay? Now again, and this has worked out to be a lot like the last problem, we're using 3 ranges on table 220.55. Number of appliances, 3. Follow that across to column C. It's 14 kilowatt again. So 14 kilowatt times the 1.15 equals 16,100. Okay, again, which transfers to 16,100 VA. Okay, yeah, VA. And so then that is the number we would use for our sizing our service conductors, based off of all these ranges. Does that make sense? Okay, now there's one more informational note we're going to look at here, and that's, or one more note here, and that's going to be note 3, right? Note 3 says over 1 3/4 kilowatt, 3 8 1/4 kilowatt. In lieu of the method in column 3, shall be permissible to add the nameplate ratings of the household cooking appliances of more than 1 kilowatt, but not more than 8 3/4 kilowatt, and multiply the sum by the demand factor specified in column A or B for the given number of appliances. Where the rating of cooking appliances falls under both column A and B, the demand factors for each column shall be applied to the appliances for that column, and the results added together. Okay, so basically what that's saying is, and I'll do a little bit of math here for you. Okay, we have 3 ranges: 4 kilowatt, 3 kilowatt, and 5 kilowatt, right? Since they're below 8 3/4, we're going to add them together, which would be 12 kilowatts, right? Now it says then we have to use the column, which in this case is going to be over 3.5, or over 3.5, or 2 of them actually. So let me make it easy on myself. We're going to change that one to 4, and we're going to go 13 kilowatt, right? And so we go down to the 3 range for the number of appliances. We follow that across over, since they're over 3.5, we're going to follow that over to column B, and it says our multiplier is 55%. Okay, so we're going to take that 3 kilowatts, or 13 kilowatt, which is 13,000 watts, and take it times 0.55, and we're going to get 7,150 watts, right? Or 7.15 kilowatts. Okay, so that would be the number then we would use in our calculation. That makes sense? Now, if I would have left that at the 3 like I did before, then I would have had to do them independently. Okay, so I would have added these two, multiply that number by the 55%, and then I would take the 1 times column actually it would have been times 65% because it's 2, and then the 1 times for the 3 times our 80%, which is in column A, and then take those totals and add them together. So it's basically the same thing. That makes sense? Okay, now one thing we need to do now is, like, let's say in a residential setting, a lot of times you're only gonna have one range circuit, right? And so sometimes it's a single range, sometimes it's a range and a counter-mounted cooking unit and a wall-mounted oven, you know, and they're all on the same circuit. If they're all on the same circuit, it's got to be done a little bit differently. Okay, so in that case, what we're going to do so we have a range at 9 kilowatt. Range is the burning units and the oven itself. We have a wall-mounted oven, which is just the oven, right? And then we have a counter-mounted cooking unit, which is just the top cooking elements, right? And you can look at this in a different video also. I talked about them. Okay, so when they're all on the same circuit, what we have to do is we're going to use that number of appliances 1, that row, we're going to add them up first. So 18 kilowatts. Okay, so then what it says we need to do is subtract then 12 kilowatts from that. Okay, so we have 6 kilowatts. Then it says for every 1,000 kilowatt or watts, or ever major fraction thereof, we have to take that times our 5% again. So we have 6 1,000s. So 6 times 5% equals 30%. Right? Now, if you look at your number of appliances 1 on table 220.55, follow it across your column C, it says now our base is going to be 8 kilowatts. So 8 times 8, let's do 8,000 watts times 1.30 equals 10,400 watts, or 10.4 kilowatts, or 10,400 VA, okay, which is what we're going to use for a calculation. Does that make sense? Okay, so those are the 4 ways, I guess, that we're going to be calculating our ranges. Most of our time in a residential setting, unless we have, let's say, a second cooking kitchen in the basement, we're going to use this method here, right? Because we're going to have multiple of them all on the same circuit, and they're not most likely going to be the same kilowatt rating, right? Sometimes, however, like I said, you'll have multiple kitchens, I guess, and then we have to redo this calculation using a combination of the two, right? But the main one I'm going to be concerned about for you guys right now is going to be this one right here, as though they're all on the same circuit. Okay? Okay, now moving on, we got one more thing here. We are going to talk about our furnace and our AC unit, right? So if you turn to 220.60, 220.60 is talking about non-coincidental loads. Okay, what does a non-coincidental load mean? Well, it tells us right in here that it's multiple, basically machines that cannot be running at the same time, right? If one's running, the other one's not. If one's not running, the other one is. That makes sense? And so one big example of that's going to be our furnace and our AC unit. You're not going to have your heat going at the same time as your AC going. Does that make sense? And so what it basically tells us in here is that for purposes of calculating our service, we only have to use a larger one, right? Which in pretty much every case is going to be, at least in our area, is going to be your furnace, right? Because it's going to take the most power. Now, the only caveat to that is if you have a heat pump, right? Because your heat pump is going to be running both when the furnace is running and the AC is running, right? And so then we have to take that heat pump itself factored into the actual furnace load, right? We do know that if we have a heat pump, we need to add that in, right, to our furnace because it does run at the same time. So, but just to make things easier, we're going to say our total furnace load and our heat pump load or whatever is going to be 15,000 VAs. Okay, we don't do anything with that except move it over to our calculation, right? Because we're going to have to use this whole load because this is a 2-wire line, 240 volt load. Okay, so it's going to be used when we're doing the ungrounded conductors, which is what we're figuring first. That's going to get moved over. We're going to use that whole thing, right? We're going to find out once we get to the neutral load, however, since this is a 2-wire load, we're not actually going to even use a furnace on that neutral calculation. But for this here, we don't have to reduce it, we don't have to do anything with it, we just take that and we use that number if it's a furnace. Okay, that makes sense? Okay, so today, again, we talked about the dryer, we talked about our range and our range calculations, and we also talked about our furnace. Now, hopefully a lot of this made sense. If you need to, go ahead and just rewind it back and just rewatch the parts again to kind of tell you how that all works. And of course, you can always use your code book, look through those articles in 220, and then also for my students, you can use our EWR book. It also has some examples in there in chapter 27, I believe. Yes, chapter 27. So, I hope this that you were able to understand this video. The next video we're going to be talking about is going to be our fasten in place appliances, and then our largest motor load. And then once that one's done, then we're going to do one more video yet that's going to encompass everything, all the calculations, to show you how to do the math on the feeder calculation and to figure it. Okay? All right. I will see you on the next one.